So let's get started. So a lot of people might have come across me. My name is Khesh, and I'm an application engineer here at Leap Australia. We've got offices throughout Australia and one in New Zealand. I reside in the Melbourne office, specifically Clayton. If you guys are nearby, come say hi. So the agenda for today would be I'm just going to go through just a bit of context on when automation in Ansys kind of started in general. What is the backstory of it? Python overview. Tiffany's covered most of it, but I'll just still like to touch on what is the minimum requirement at least to proceed in mechanical scripting. I'll go through introduction, just a basic introduction for mechanical scripting. What is the capabilities of mechanical scripting and what are the limitations. And I've got two models. I've got 2 or 3 models set up. One is a full model. I'll set it up from scratch, an end-to-end example, as I like to call it. And then I go through the key concepts. So why I have a full model first before going through key concepts. Key concepts are, if I just have key concepts right away at the start, it's kind of a circle. So without knowing that, you can't know this. So I just thought I'll have it after the one full model, so people have already seen example, so it makes more sense. And I've got a beacon connection script as well, which I'll be going through a pretty straightforward, simple case. And to finish it off, I've just got some, taking pictures from mechanical and where to find more help, resources. And finally, we've got some time for questions. Okay, so let's keep going. So overview of automation and Ansys in general. Okay, so ever since 2019, as I've mentioned in the last session, Ansys has been pushing for automation. Okay, and the backend language is Python. Like we should have known that by now. In Python specifically, so some of the modules don't come in. So when you copy existing code from online, Stack Overflow, or Google, or even my previous codes, just be wary of some parts of the code might not work because it might be a different module, or a CSV module is not available, or a math module is not available. So just keep that in mind. And also every release of Ansys, the API is updated. So the syntax for a particular piece of code might not be the same from 2020 R2 to 2021 R1, for instance. Okay, that's not my experience so far, but that's what Ansys has come back and told me for now. Okay, so in the back end, so I had a lot of questions yesterday. Some of the clients were using 2019 version 2019. I just found out 19.2 did not have it, even though the beta version was turned on. So I would still highly suggest everyone to download the latest version, 2021 R1 or 2021 R2. So it's everyone can be on the same page and we can take it from there. So let's keep going. Python overview. So I think Tiffany's covered most of it. Data types. So we've got floats, integers, doubles, triples. We've got control flows, if this or that, and so on. We've got for and while loops, which I'll be going through extensively. And finally, Tiffany's covered CSV module just before this. So those are kind of the main basic requirements. At least there's a few more things with Tiffany was talking about, like a with handle in Python. I've got a separate slide for that later down the line. And there's another thing called transactions and manipulating lists and strings. I just got a few slides for that as well, so that'll be good. So mechanical scripting introduction. So why do we want to use mechanical scripting? So the most obvious answer is, you have you want to automate a particular tedious task, it's just labor work at the end of the day. You don't want to be sitting and doing it for hours and hours on end. Okay, so that's the short answer. And obviously, if you can automate your processes in software, you have more time to critically think about your problem in depth. Okay, so I'll be walking through the mechanical API, so which is the documentation that Ansys provides to access all the objects inside mechanical. And I'll also be creating a button in the later down in one of the tutorials on how to when you have a script, you can make that into a button. So whenever you want to run the script, you can just press the button. Okay, and I just wanted to touch on this. So ACT, so the extension or the abbreviation of ACT is Ansys Customization Toolkit. So these are for a bit more hardcore users who knows Python in and out, who can work with XML and HTML and so on. So the whole process of that is you can edit the input file, which Mechanical writes before going to solve an APDO. So you have control over the FE, which we wouldn't be going through it today, but Mechanical scripting is a good starting point to write ACT apps. So I thought I'll point that out as well. Cool. So in this section, so just a kind of intro section 1, I want to go through the scripting GUI. Tiffany did touch on it, but I thought I'll expand on it a little bit and what I use on a daily basis. I want to go through the APIs that I've been talking about for quite a bit. So it's called Application Programming Interface. And I'll also be going through entry points as well. I'll just expand on what that means later. So it looks like I've got a few questions. I'm just going to take a little breather here. Looks like I've got a few questions on the chat. So one's from Rahman. So where can you find import CSV? Rahman, I'll go through it in mechanical scripting. You can just write import CSV at the top. So Python will import the CSV module externally. So you don't need to do anything about it. Another question was, can you please share your email ID? Yes, I've got my email address in the last slide. Or Tiffany, if you want to just paste my email in the chat, that'll be fine too. Another question from Ian was, running a Python script normally, you'd have to install the CSV library first, pip install CSV. So as us, I'd be interested, how do you install libraries for Python? So you don't need to install libraries from Python. Yeah, sorry, maybe I misunderstood the question. So import math, CSV, and you've got few other modules that I use on a regular basis. It's already pre-installed with your DLLs in the background. So you don't need to separately pip install CSV like you do on an IDE, like a standalone Python runner per se. Okay, and another question was, will you be running an intro to ACT apps course? Yeah, I think we're more than happy to run one if people show interest, but I think most of the scripting should cover what people want to do. What people want to do 90% of things, and the ACT might be for the top 10% of people who want to have more control over this. Okay. Another question. Sorry, guys. I was a little bit late. Can you clarify something? Can I write script in Ansys 19.2? So, Freddie, I was just saying I tried to open scripting in 19.2, and it was a beta version, so you had to do a few things to get it up and running, and it's very temperamental. I tried running a few scripts yesterday, so I wouldn't recommend it. So if you can, Freddie, if you can open it in 2020 or better 2021 R1, that'll be good. Okay. All right. I'll keep going. So we've got the mechanical scripting GUI. So as I think Tiffany's gone through most of this, but I just want to still expand on a few things here. So as you can see, you've got your your basic functionalities at the top. Even though that's a big run button right here, it's not the run button. Some people might have come across it. It's actually the debugging button, which is there. The run script is right here. So this is editor. So any script on the editor wouldn't be run automatically unless until you press run. You can save the script, you can open a new script, or you can just hit new and create a new script as well. There's a few snippets as shown here. These snippets are pre-built from Ansys, so that's good, so that you can go through. I think that there's quite a few examples how to add a pressure, how to add have a quantity units to work with the units, and a few examples. So that's good. I'll just go through that when I open it as well. And show button editor. So once you've kind of you're happy with your script, whatever you've got, you can make that into a button, which will then come up in the tab below, which I'm pointing out right now. Okay, so scripting, script editor. What I use is VS Code, Visual Studio Code. It's free. It's open source as well. So if you guys want to use it as well, free for you to download it. I think if I'm not wrong, it's a Microsoft product, and it works well for me in even version control and Git and everything. So these are some of my scripts that I'll be going through today. You can open your whole folder structure and so on as well. Okay. So I just want to go to this. So this was one of my examples later down the line, but I just want to go through a few snippets and everything. So if you want snippets, you can either you go to insert snippet here. You've got example. I said there's an add pressure example. So if I add, it'll go through how to add a pressure to in this case I think it's a face if I'm not wrong. Um, Let me delete this. They've got comments as well. So anything starting with a hash is a comment. I'm not sure if Tiffany's mentioned that in the first session, but so these don't get executed. Only these code here get executed. Um, Let me delete this as well. So you've got a few things here. What else do you have? I think help us. So you've got object by name. So any syntax, if you don't know where to start, I think this is a good place to start. So when I started learning this, a lot of my learning just came through going through the snippets and just adding one by one. So this just gets you the first analyses, which is in our case study structural C5. So a few things like that. So you can go back to help us. And if you want to add a quantity, so this is something new. So quantity is a data type used in Ansys, as far as I know. I haven't used it in anywhere else, but yeah, I don't have much coding experience as well, so wouldn't take my word for it. But quantity is something. So if you want to say this is a length, for instance, or you're defining a path across this particular beam, and you want to give it a length to the path, so you're giving it 1 mm, and then the actual units is mm, right? If you want meters, you can write meters, and in the solver it'll keep it consistent in the backend, so you don't need to worry about units for now. But the other way of I found out defining is also you can just write 1 comma on quotations, you can write so that's another way of defining units. So there's a few ways, so it's really up to you on how do you want to define a particular a number and a variable, right? Whether it be acceleration, pressure, length, force, etc. Okay, so let's go back. So what is this API that I've been talking about for some time now? So API stands for Application Programming Interface, and how I'd like to think about it is it's almost like a contract between us and in this case Ansys, right? So our end of the contract is to request for information in a particular syntax. Okay, so that's our end of the contract, and Ansys in return will give us the information that we request for. Okay, so anyone who's got extensive coding experience would have come across REST APIs, which are basically get, set, put, and delete. In Ansys, there are predominantly only two APIs, quote unquote REST APIs. I say quote unquote because it doesn't really relate to Ansys, but we still use it because it's an API. So in Ansys, there are predominantly only two APIs, which is get and set. So you can either get the data, which is already presented, and or you can just set the data, which is like us, giving an input, right? So it's an output and an input. So get or set. Okay, so how would you get access to this API? There's a link here that I pasted. It's open to public, if I'm not wrong. You don't need any login, or you can click on this link when you guys get the presentation. But for now, I have it up in my browser. So once you open, I'm using the downloadable API XML reference guide. So I like the local one because it's just faster. If it's online, it's a bit laggy. So just try to download it and open it and save it on your desktop or something and bookmark it. And in my case, I bookmarked it. I've called Mechanical Scripting 2021 R2, and there's one for R1 as well. So I had both here. So if you open that, so this is how it looks. So let me just open it again. So R2. So this is kind of the home page. Mechanical is mechanical, and you've got a bunch of stuff here. Okay, so if you want to, add acceleration quickly, let me just search for acceleration. Just taking some time. You can see, so under analysis methods, there's acceleration. You can click in, and there's a few things here. So if I click on acceleration again, so there's methods and properties. So we haven't touched on classes. Classes in Python, just because we didn't have time. But so every class would have an inherent method. Okay, so what that means is these are all pre-built to that particular class. And in this class, in this case, the class is an acceleration, and every class also has functions, right? Or properties. You can say it either way. I learned it's a function, right? In this case, the functions are what you would change or edit or get or set and so on. So for a force, a function might be the magnitude or the components, or the so set XYZ, force, magnitude, and whatever it's there. In an acceleration, you can see so X component, Y component, Z component. You can click in to see what you can do with it. So get the X component. In this case, you can only get it, which means you can't actually set the property of the acceleration. Okay, so the documentation is very extensive. So you can keep going with how the links are. You can just keep clicking and keep going in. Boundary condition, acceleration, and it comes back as well. Okay, so this is the API guide that I'm talking about. This is kind of the bread and butter once everyone starts getting into scripting a little bit. But most of the features that I'll be going through can be come across through recording. So what I mean by that is you can record the code. So the recording feature is right here. So you can hit start recording. So not all the workflows will not be recorded, as recording is under development. So you can either turn on and off a few things as well. Okay, so not everything you do in the GUI would be recorded here. So that's something to keep in mind of. So what I'll do in this case, I'm just going to pick a face, and I'll add a fixed support in this case. Okay, I just want you guys to see our pressure, to see how it comes through in the recording. Okay, I'll stop the recording now. So you can see, so analysis, it got the analysis by ID, not idea. I'll explain why. So you might have different analysis here. So what I mean by that, and how you guys have if you go back to Workbench, you might have analysis setup, multiple analysis setup. So either modal, harmonic, transient, and so on. So anytime you update or sorry, I just had a question. I think there's a few questions there. Okay, there's a lot. I can't see the debug option. Let's start from the start. Parnas, I'm not sure. I'm not sure what version you are using, but the debug option should. And again, I've got my beta options turned on. Even here it says, I'm pretty sure at the top it says is under development. So I've got the beta version turned on. So that's another issue. So, but by the looks of it, you're using 2020 R2, if I'm not wrong. But yeah, we'll go through it after the session. I'm not sure why you don't have it. Next question was from Mark in 2020 R1 doesn't have record or debug buttons. I think the same question. She's asked, I can only see snippets. Can you please copy the API link here? Thanks, Stephen. And Tim's asked, is recording only available in 2021 R2? No, it's available in 2021 R1 as well. And if I'm not mistaken, 2020 R2 as well, because I remember using it when I started learning it 2 years ago or a year ago. Okay, she's using 2020 R1. Tiffany, if you could just open 2020 R1 in the backend and just check the recording button, that'll be good. Okay, and I'll keep going on with this. All right, so going back, you can see, so analysis 35, which is our object that we've defined here. They're saying analysis 35 dot add pressure. In this case, this is a property of the analysis, so that'll be a function of analysis. And then what we're doing is, this is what kind of confused me when I started learning mechanical scripting. Is the selection manager, the selection info in mechanical is set up in a weird way, for lack of a better word. So what it does is, I'll just try to break it down one by one. Here. So the first line 9. Selection equals API selection manager, blah, blah, blah. I'm not going to get into it. So what this does in a simple term is, when we have selection managers here, so a face or a body or an edge, that's what you're doing here. So right now it's geometry entities. So if I want to see what other options are there, I can copy and paste this, go back.
Khesh, You got another question? So they ask what is certified stand for?
Oh yeah. Well, I'll get to it. Where is it? There you go. Okay. So in mechanical, everything works in an ID basis. That's why recording is bad. So recording is good to know the syntax, but bad in sense of everything's referenced by ID. For a human being, 35 doesn't stand for anything. Like, the usage is us. Even for me, it doesn't make sense, right? But what mechanical does is, if I just pick a face, the reference ID is 53. I can see that in mechanical. Okay, so that face would have an ID of 53, which is what I mentioned here. So geometry, reference ID. So every node would have a node number and also a node ID, similar to an element. Okay, all these things can be accessed and manipulated using mechanical scripting. Okay, in short, 35 does not mean anything, right? And that's why it's bad. So I did a similar example here. I just added a fixed support. So as you can see, get object by ID 504. What is that? What does 504 mean? It doesn't mean anything to me. Okay, but the whole point of recording is to get the syntax so that we can expand on it. So once you recorded this feature, what I then did was, so this was the recorded code, and this was me coding it by hand from scratch. So you can see I've set up the model, and I said est api.model. Project.model, and I said analysis. I want the first analysis, and then I did analysis.fix support, and then I gave it a location, which was a name selection in my case. Okay, so in this case, as you know, as you rightly asked, the 35 does not mean anything. So coming back to this, you can kind of see what options are available, what properties are available here. So each, when you just scroll through it, each will give you a description of what the input and the output would be. So you can select a few things here. You can either select geometry entities, which is edge, body, your face, and so on. You can select mesh elements, mesh nodes, surface specific, and worksheet. So what this does is, in my head at least, to make it simplified for everyone else, is just to filter whatever you're choosing. Okay, after you choose the filter, you want to actually pick what you want to pick. In this case, I picked a face which has a reference ID of 53. Okay, how do I know it has a 53 reference ID? So let me show that as well. If you go there, let me go to home and then selection information, make that bigger, and I'll hide this, hide. You can see there. So if you click the face, and you can go there, and you can see the reference ID, that's 53. Okay, and this is bad because if you go back to Space Clean or whatever your geometry editor is and change anything, right? In a sense, you make a small change, your reference ID are prone to be changed as well. So that's why it's not we're not going to advise it. But the whole point of recording is that we can get the syntax without us going on to the the API guide and spending heaps of time just to find what we need. Okay, so we're selecting, so we got the geometry entities, so which can be edge, face, body, vertex, or anything, and then we pick the face we want by choosing 53, the IDs, and then we give it pressure dot location because we added a pressure. The location of the pressure should be the selection we just got. Okay, so in short, that's how the selection manager works, as well as that's how the recording works. Okay, so let me just go delete this. Get rid of all this or come back to this. I had this solved for another.
Khesh,
Yeah.
there are a few questions that you might want to address it.
Yes. Sorry, Maxim. Does scripting require additional licenses? No, it does not. It's free for everyone. So when it comes to ACT, there's some requirements, but I'll go through it later down the line. But scripting wise, whatever I'm doing right now can be done with any version. Okay. Different faces will have different IDs. Yes, different faces will have different IDs, which I will also touch on in an example. Okay. Is there any other question? I think that's it. If I did miss anything, Tiffany, just pick it up and let me know.
You got another one.
Another one,
Just that
sorry.
one.
Maxim, can we use scripting for Workbench without using licenses? You mean in the background? I don't think so. I know why why you're asking that, so that people can use, if you're running something in batch or something, people can use the GUI. No, I don't think you can use scripting without using the prep post license, at least if I'm not wrong. Or if you're solving, you need to use a solver license, but I think you need a prep post at minimum. I can see what the licenses have checked out, but yeah, I'll keep it for later. Okay, so let's go back to the presentation. So yeah, and Ansys help has a lot of examples. Well, most of the script, which is again used by a lot of us, would be in Ansys help. So if I just go back to Ansys help, there's a section. So under mechanical application, I've got the local help, by the way. Online help is available as well, but I just like the local help because it's faster and I use it on a regular basis. You can see there's quite a few examples here. I'm not going to go through each one of them, but small examples, but I think these are pretty useful. They've got the code and they've got some form of explanation as well. So if you guys need, just feel free to click in the link. This is an online link, by the way, so it'll work for anyone. So that's there. And also they've got an end-to-end example. What end-to-end means is it's a full-on example. What I mean by that is if I go to static structural, they've got the model that they use for, they've got the mechanical model, and they've got the script which can be downloaded through the link here. So if you scroll down, you can see it's setting up boundary conditions, coordinate systems, joints, remote points, etc., etc. Okay, so this is kind of one of the examples that we'll be going through today. So don't worry about that for now. Okay, but if need be, you've got your transient, how you manipulate transient data, and so on. Okay, so I've given the list here as well. Also, the link is here. You can click, and once you get the presentation, you can click in and open it. Cool. So this is end-to-end, which I just showed, and entry points. So I think this is kind of one of the most important parts that I wanted to talk about. So API entry points. So these are the gateways to the mechanical interface. Okay, that's how I'd like to think about it. So the multiple ways you can access the same thing, right? You can either access to data model, or you can access to the graphic window or the tree, right, as seen on the right-hand side entry points. But the most common setup, but I call it the most common setup because I'm the only one who uses it quite often, is this one, because I find it very useful. I like to break things down. So model, mesh, materials, analysis, solution. So anything, any properties I want to find under analysis, like a fixed support, I can write analysis dot fixed support, add fixed support. Okay. So what I'll do is I'll copy paste this common setup that I have in code in the chat so that you guys can, uh, keep, I pasted it in the chat, by the way, so you guys can copy paste it in your scripting menu. Okay. So with that said, I think we are ready for an end-to-end example. So this one is a trailer model. So what I'm going to do is I'm going to set up a remote point and then set up point mass. I'll go through a Reveille join. I've got a Reveille join if I'm not wrong. I've got some frictionless contact or MPC contact. I can't remember off my head, but I've got some contacts there. I've got some meshing methods, meshing sizings and so on. And I've got a few boundary conditions. So I've got a fixed support, an acceleration, and a pressure as well. And I'll also go through some result, how to see the results. Okay, so that's what's scoped for this example. So what I'll do, let me open my model. There you go. So that's my model. So you guys tell me how you guys want to run this, because there's a few ways I thought about it. One is me recording what I normally would do, right? So use a record feature to record it, and then how I'd go about cleaning it up. Or additionally, what I can do is, let me copy the general setup here so that I can just and run it. So that's the general setup, which is in the chat as well. People can copy it and run it. Additionally, what I can do is I can use the general setup and go through it one by one and set it up manually, like code it up. So it's really up to you guys on how to, how to run this. I've got a question from Ruckman. It seems like the function is following certain calling hierarchy. Do you mean, what do you mean by that, Ruckman? Can you just expand on that a little bit? You mean it's following the tree? That's kind of how I got set it up. Thanks, Tim. Thanks for that, Tim. Yeah, well, that's how I have it set it up, though, Rahman, because it's just logical in my head, because every other client is going to go through the tree. So you've got your model, you've got your geometry. I don't have materials because I do have materials, but I don't use that often at all. Coordinate system, I don't have a coordinate system because, again, I don't really play around. I'm not changing any coordinate system here. And I've got connections, and I think analysis and so on, because it's just the most logical way to me. But you're right, there is a certain hierarchy which follows the same tree as well, makes it a lot more intuitive for general users who are not hardcore Python enthusiasts as well. Okay. And the former option of recording your setup seems more practical. Yeah. Okay. So what I'll do is I'll start recording a few things. Maybe I'll start recording the point mass. I think that's a good example. And then I'll go through how I've got the point mass set up in my code fully as well. So the point mass would be under model. So let's add a point mass first. Let's to get a point mass, you need a remote point. So let's go ahead, add a remote point first. Let me start recording. Sorry, let me delete that. Delete, start recording, and then start it. Insert remote point. You can see it's very verbose as well. So that's something annoying. You can see region, context, menu, action. That doesn't mean anything to me. End region doesn't mean anything to me as well. And then I'm going to pick these two faces, Control F, that face and that face, go apply. You can see it's picked up the ID of those two faces and it's applied. Now, what I want to do is I want to manipulate these numbers so that I can, I've got some numbers in head. So what I'll do is I'll write -500 here, and the Z coordinate, I want it to be 1000. So the point mass is sitting on top, in that particular area. You can't see anything now, but that's where it's sitting at. Okay, so now what I'll do is I'll add a distributed mass or even a point mass. I think I want to add a point mass to this. And this point mass would be scoped from my remote point, which I literally just created, which is called remote point 1. I think just remote point, right? You can see it. And I want to give it a mass of, I don't know, doesn't really matter for now. I'll just give it a mass of 5 kgs. Okay. So let's go through the setup now. I'm going to stop recording. Okay. Let's go through what we've got so far. Yeah. All right. So I start off with making by making a remote point. So model.remote point. Again, that remote point 14 makes no sense to me, right? And I don't want to have a name that that big or that large. So let me code up how I'd code it up as well. So remote point logical name would be RP1. In this case, it's RP1 equal, and it's going to be under model. You can see it's under model. So I'm going to write model dot. Once you write dot, so this is the autocomplete. The autocomplete is available both in the editor and the shell. I think I have a slide here on autocomplete, if I'm not wrong. Where is it? Autocomplete. So it's very useful for people to use. So autocomplete will give you the methods and the properties of a particular class again, right? Without getting into too much, it'll just tell you what's in that, what's in model, right? For example, a model would have add remote point, add remote mass, and so on. Analysis system would have pressure, add fixed support. Whatever you get in your tree would be, I'm hoping, Ansys have included in the APIs to be in the functions and the methods as well. Okay. Sometimes when you hit escape, the drop-down menu, the autocomplete would disappear. and the shortcut to bring it back is Control and spacebar. This has saved me a lot of time. If not, you always go back and hit write period again for it to come up again. So what I mean by that is if I hit escape now, it'll go away. So previously what I'll do is I'll go back and then hit dot again. But if I'm not wrong, you can just go Control Z and it comes up as well. Okay, so in this case, I want to add a remote point. So add remote. There you go, add remote point. It's a function. So what it says is creates a new child remote point, returns the object created. Okay, so I'm going to hit enter now because it'll automatically fill it out. And then because it's a function, you need to have a parentheses at the end. So that's RP1. And then what do I do? Once you've created a remote point, I select I go through a selection type and then add the faces, right, with these IDs, and then give it the selection. Okay, but in this case, in my case, what I've got is I've got a name selection, which I have already prepped for, if I'm not wrong, I think it should be railway track. Yeah, there you go. So railway track is those two faces. Okay, so this is the most kind of used code that I would say in my last 1 or 2 years of using mechanical scripting. So what I'll do is, so it's a name selection, right? So I'm just going to call it ns equal ext API. Again, syntax, I'm not going to worry about it. Dot data model. To be honest, I think if it's, or no, it's not there. So I'm just going to write data model dot get object by name. Okay, so I'll just explain what this means. Again, bunch of syntax. I don't care. You can copy it. It'll be in the example or the documentation. Doesn't make doesn't mean much to me. So this is the function that I'm interested in. So get object by name. What this does is it'll go through your tree and it'll find whatever object you have by its name, right? In this case, I've got it as a railway track. So what I'll do is I'll do it interactively so everyone can see what's happening here. So ns equals, I'm just going to copy paste this line, copy paste it, and I'll open bracket and it'll tell me as well. So this is going to be, this is a list. It's going to return a list because it says I list there, and it says get object by name, and in the parentheses it says string name. So we know we need to, the input is a string, right? Syntax for string is a quotation point between two, and then in this case I want to get railway, so railway underscore track, because that's how I've got my name selection set up. Okay, so if I enter now, I've made a mistake here because I use it on a regular basis. I know what mistake it is. So if I go ns, I told you guys get object by name is a list, right? I can't give multiple selections to my multiple name selections to my remote point. Okay, so if I go ns list, it is a list right now because you can see you can see the parentheses here, the square brackets. So if you want to get the first index of a list, it's ns square bracket 0. So indexing in Python starts off with 0, as Tiffany mentioned yesterday. So if I go nx0, it'll just get that particular object, that one thing in a list. Okay, so ns is going to that, and I'm just going to copy this. And we know I just need the first index from the list. I'm going to go hit 0 there. Okay, so that's my nx now. So instead of going through all of this, what I'm going to do is, so we've got RP1. I'm going to do this interactively so people understand, right? And so we've created the remote point here, which is RP2 in this case because I've recorded one of them. And then NSO, I'm going to just do NSO again. Okay, now RP1 dot, what do we have here? We've got geometry and nothing there. So we want to scope a location, right? So it's literally location, and it says get or sets the location. In this case, I know I want to set it. So the shortcut, or you can go type equals and so on. There's a few ways to do it, but what I'll do is rp1.location equals ns, right? And the ns is our railway track. Okay, if I hit enter, so there you go, that's scoped. Okay, and now if I want to manipulate, because if I'm not wrong, I changed the y coordinate of the remote point. So rp1 again dot y there you go. It already comes up y coordinate. Again, it says get or set. Both, I'm not sure why there's a component and a coordinate, but in this case, I'll be using a coordinate because that's what I can see in the GUI right here. So y coordinate says get set, and then what I'll do is equals. So this is where the quantity that I was talking about comes in. So coordinates would be in millimeters. So what I'll do is quantity bracket open, and the number I gave it was -500, comma, the units are in millimeters, Okay, done. So that's changed it to -500. Okay, so whatever I did here, whatever this and this did here can be broken down. I'm just going to delete this for now. Okay, so I'm going to go delete. So whatever I just did there can be broken down into these two, like 3 lines of code. So you can see how how powerful we can record it and then go ahead and manually edit it one by one. So you don't have these verbose, extensive piece of text, which doesn't really mean anything to us. Okay, so those are the remote points. Again, I've got a few things here. I'm just going to copy paste what I have from my text editor, which I've already have it done. So I'll just go through quickly. So we're adding the remote point, name selection of the remote point. When applying the name selection to the location of the remote point, and we are setting the x coordinate, y coordinate, and the z coordinate, and that's it. Okay. So now I think we're running a bit short on time as well. I've got a lot to cover, so I'm just going to skip through this. So similar concept. I'm not going to go through it one by one. In this case, again, it's under model. We've added a point mass, and we changed the point mass, the magnitude of the point mass to 5 kilogram. Okay, and I have already have a point mass script which does just that. So point mass is under geometry. And then I added a point mass, and I changed the quantity pinball region, right? So if I go back, where is it? So the pinball region would be, I think once it's set, it's there because I've already set it without changing it. It's default grayed out for now. But when I run the script again, this I'm going to delete this. We'll run it again just to see how all just the script plays out. And I'm changing the pinball region, and I'm getting the object by name. In this case, I'm getting the remote point that I've created before. Okay, so it is remote point here, but I think technically the first one you create is always going to be remote point. The second one is remote point 2, and so on. So that's why I have the first one as remote point, and I'm changing the quantity of the mass to 300 kgs. So what I'll do is I'll go delete this. Right, I'll delete whatever I have, remote point, delete that.
Khesh,
Yeah,
before you go on, there are some questions in the
questions as well.
conversation.
Sorry. Yeah, okay. There's quite a bit. Now you set the y coordinate to -500 mm. Can you assign? Okay, sorry. I'll start from the start. Maxim, why don't you have any lines about x coordinate? I don't think I changed the x coordinate, Maxim, if I'm not wrong. Okay, that's why I don't think I have any lines about x coordinate, but here I do because I don't even think I need to be honest, because yeah, I don't change anything. I don't even need this line. I can take this line off, to be honest. Yeah, I don't need it. Okay, Rahman, now you set the y coordinate to -500 mm. Can you assign that to be a variable? Yes, that's not, I don't think that should be an issue. I think I can try it now actually. So let's try it now. So let me set a is equal to 500. I've actually never done this before, so okay. And I want to set RP1 quantity to be 500. Let's do it. So RP1 dot y coordinate. If it doesn't work, I'll get back to you. Quantity open a comma mm. Let's change it to, oh, okay, it's going from -500 to +500. Yeah, object not found. Yeah, we can we format? Can we do string formatting? I'm just gonna try something else as well. Give me a sec. I'm gonna have this as string format. Call it a. Yeah, expected flow. Yeah, Maxim. Was it Maxim? I think it was Rockman. Yeah, I'll probably get back to you on that one. But I'm sure you can. I think I've done it before. I just don't have it off my head to be honest, off my memory. There's a few string formatting techniques you can use to get the variable inside there, and then you can have the variable as a user input at the very top, so you don't need to keep, you don't need to hard code this. Okay. Um, what is this? Can you explain why you put 0 at the end of the NS list? Yes, I can. Okay, cool. So let's create a list now. Which let's call it a bunch of names. All right, so Apple, um, Batman. Uh, they're not there.
We're
And
never
then
going to get through the content if you don't get on with it. These
sorry.
questions are from people who didn't pay attention in the last class, I think, and some of the questions are questions that have already been answered as you progress through. So I think
Yeah.
we should just tell everyone to leave their questions till later.
Yeah, I think I'd rather address them right away. But yeah, we can go through the content a bit quick as well. I'll just finish this because I've already started. So I'll just go TZ. So NS is that. So if you want to get the first element of NS, it's 0. Right? If you want to get the second element, is 1. Right. So that's why because NS was a list. Yeah, right. I want to get the first element of the list. That's why the 0 is there. Okay. The reason being, you can ask why is it a list? Because the railway track can be, you can have multiple NS. What I mean by that is the railway track, in this case, it's a face. You can have a body selection called a railway track as well. So then how does it know what to pick up? So that's why I gave it 0 there. Okay. Cool. Let us keep going. So what I'll do is I'll delete my point mass, delete that, delete remote point, delete that, and I'm just going to run this. Okay. So if I run it, you can clearly see point mass is created and also my remote point is created. Done. So I think for this particular setup, I had what else did I have? I had another remote point and a point mass, but I don't want to go through it now. Next one is connections. So I've got a bunch of connections here. So what I have is I'll go through it here. So this body, this kind of cylindrical body, if I hide it right here, will be connected using a Revolut join. And also I'm going to have a spring between this face here and this face here. Okay. So we can do it again. We can follow the same procedure as before. I can record it and go through it, or I can just go through what I have so far. All right. So let me just go record this. Just record this one, and then I'll show the script that I have. Okay. So let me add a joint insert. Let me record it first. Record. Right click. Insert joint. I'm gonna hide this body, and then pick Control F. Face selection. Go down. Zoom in, and I'll pick these two faces here. Okay. Now show all bodies, pick that body, hide all other bodies. I've got this. So again, face filter, these two faces and those two faces, and I'm going to apply there. Okay. That's done there. So what I'll do is now stop the, give me a sec, stop the recording, and I'll just go through the code like we've done before. So yeah, connections is under model. So we need to start off with model.connections. I've already got something called connections here, so you can just start off with there. And under connections, there's a function called add joint. So you can just go connection.add joint. And what you're doing is then you're just setting the faces of the reference and the scope body. So in this case, again, because you're recording it, you are only the IDs come up, but you can automate this using name selections as well, which is what I've done. All right. I think we're running a bit short on time. So what I'll do is I'm not gonna go through the full thing here. So I'm just gonna copy paste the code that I have and explain how the code works instead of me writing the code from scratch. Okay, so I'm just gonna paste it there. So this is the code that I have in that I have previously created. So let me show all bodies. I'll delete this for now. All right, and I'll have where the joints are here. And I'll go through this. Okay, so I've set up name selections. So similar to, I don't know how many you guys use Fluent. In Fluent, everything will be picked up from name selection. So I think that's what Ansys is kind of pushing for as well in mechanical side. So I've set up name selections for these joints. So you can see if I had this, you can where are my joints? I think that was in the Control B. Hide this. You can see the highlighted area. Okay, and JP1 corresponds to, so that's top. So JP's joint, and then T is top. One is just the index that I've given it, and then bottom is if I show all bodies and hide this particular body F9, and these are the bottoms. Okay, so what I did is I went ahead, I did the same thing for all the 4 joints. Now I've got everything under under name selection, so I can pick it up easily instead of me doing reference IDs, which is just a waste of time, and you don't know it's 2255, right? Again, not interested. So that's why we go through name selection. So what I do is I did something a little bit fancy here. I'll just show what I did as well. So what I did was I created insert connection group, and I renamed that, and then you can go insert add a joint. Okay, this is exactly what I did here. So what I did was connection.add connection group, and then I changed the connection group name to joint. So I'll do that manually now. So JOINS, but I just did it through the code, which is right here. And then for IDX in range 1 to 5. Okay, now let's go through this. So range 1 to 5. Let's just see what that is. All right. So you want the index to start from 1, and you want to finish. You want to have 5 characters. No, this is not the right way to say it. Tiffany could help me out here. How do I explain this? So the starting point of the list is 1, and the end should be 1 n minus 1, which is 5 minus 1. Okay, so it's a bit complicated. There's syntax guide out there for Python which can clear this, but for now you just have to take my word for it. So that'll give you a list of 1 to 4. Why do I want a list of 1 to 4? Because I've only got 4 joints here: JP1, T1, JP2, JP2, T3, JP4. Okay, so what I do then is I loop through those 4 loops, right? So what does looping mean? So for IDX in range 1 to 5, for people who don't know what looping is okay. So IDX is it's index, right? So that's the full form, index. Or you can have that as what. So this was one of the hardest concepts for me to understand. You can have that as anything you want. So you can have that as item, or you can have that as Superman, right? It's really up to you, right? It doesn't need to be anything. So it's what that Superman means is when the loop goes through it one time, the list, right? This particular list, it'll go from, so 1 would be Superman at once. The second time it'll be 2, third time it'll be 3, fourth time it'll be 4. So just to showcase that, I'm just gonna go Superman plus I don't know, 5, 10. Let's do 10. Okay. So let's go through this. So for Superman, so for 1 in range block in this particular list, add 10. So I add 1 plus 10, which is 11, and then I print it because I say print 11. And it goes to the next one, 2 plus 10, 12, blah, blah, blah. You get the point. Okay. So that's what my first line of code does here. All right. So what I go through it, I loop through that particular list of 1 to 4, this list right here, and then I add a joint for because I've got 4, I add 4 joints. So that when I run the script, you guys will see it. I add 4 joints, and then I did something a little bit fancy here. So what I did here was I call it JP joint bottom, joint top, and I don't want to be manually setting it. Okay, for every time I want it to index automatically. So what I mean by that is if I go print JP say B, and then you'll understand why I'm putting the 0 there. It's called string formatting. Again, a Python like string formatting, basic Python. You can just Google that. You can go format, and so why I'm doing this is I'm going to call this Superman. Okay, so if I put Superman inside quotation marks, it's going to take it as a string, right? I don't want that. I want this to be a variable, right? So you put this curly brackets and 0. If you want something else, you can do the same thing. You'll put 1, right? That's your next one. So if you want to have another variable, you just go comma, I don't know, Spider-Man. I don't have that variable named here, but I'm just saying, for example. All right. So I'm just going to take the one off. So now, if what are we expecting here? Can someone say what my output will be if I do this? Any answers, guys? I'll give it 10 seconds. No? Yeah, there you go. So exactly. So your Superman, your last, because this is stored temporarily, not JP Superman. That's exactly what I thought when I started this. It's not JP Superman. I'll explain why. So Superman from the previously stored list is 4, right? When the loop finishes, that's the last value of Superman. So if I write Superman here, it's going to give is when it loops through, that's the last value, right? What I'm doing is I'm going to go JP0, right? 0 is just me, this curly bracket 0 is just me formatting. I want a variable here. If I put Superman here, it's going to be Superman, right? So I can just showcase that so people understand the difference, right? So I'm just going to write Superman. Right? So you think that that's a variable, but that's not a variable, right? Because it's inside a quotation mark, it's a string. So that's exactly why you put a curly bracket there, 0, and write format Superman so that you can get JP4. So I did that for top and bottom. So I did for JP. So it's going to just whenever it loops through, and in this case, my index or my Superman is IDX, right? It'll be JP1 the first time around, JP2 the second time around, JP3 the third time around, and the fourth time around, right? Because I've got JP1, 2, 3, 4 here. Okay. And then I just set the joint dot reference location to JP bottom, which is here, and JP top, which is here. Okay, and that's it. So what I'll do is I'll run this particular. Let me delete this. Do I need to delete anything else? Nope. So let me delete my recorded version because I don't like it. And I will run it. Okay. So what are we expecting? We're expecting 4 joints. Yeah, under folder called joints. There you go. So we've got JP4, that corner, right top corner, top left corner, JP2 and JP1. Again, you can play around with the coordinate system, but again, because this was just a basic intro, I've tried to keep it simple. Okay. Cool. So what I then do is I do the same thing for Springs, right? Same concept. I'm going to copy paste the script here. I'm not even going to record it this time around because we've gone through this. Sorry, and I'm going to paste it there. Same concept here. If I go to my Spring NS, I've set up my Spring NS. Instead of JP, I've just changed it to SPB, right? SP being Spring, B is bottom, P is top. That's it. So this is SPB1, and then SPT1 would be the top surface. Sorry, let me change rotation. Yeah, there you go, at the top. Okay. So instead of calling it IDX, I call it KDX, but as I said, it doesn't matter. You can call it Spider-Man, Superman, Batman, whatever you need. All right. So what I will do is I'll just run this code copy and run it in the shell so that, okay. I didn't put this in a group, by the way, just letting you guys know if you guys want. not group it, right? But this particular case, I grouped the joints. I didn't group this just to show if it's possible. Okay. So our joints contacts are set up. So what's the next step? Our next step is to mesh. All right. So there is a obsolete mesh here for whatever reason. I'm going to clear it. I don't know why that's there. Clear that. And for meshing, I've got something set up called mesh here. So most of the meshing would come under that. But since we've gone through this, I'm not going to be recording it again. I'll explain two ways of going about it. So I'm going to copy two pieces of code, which essentially does the same thing. You guys can tell me the difference. I'll make this bigger. There's no point having it so small. Cool. So we are adding a method. We are adding an automatic method. I'm creating a filter, a geometry filter, so that I can pick any face, any edges, bodies, etc. And I'm picking a bunch of bodies with these IDs, and then I'm giving it to the method location, right? A lot cleaner way of doing this is this. So in this case, I've obviously added a sizing instead of a method, but I've added a sizing. I've given the location of the sizing to be something called mainframe. So that's under here. So if I go mainframe, oh, that's the mainframe. There you go. Okay, the upright frame is all the like here, and I've got brackets, rods are these, and I've got rod faces. Rod faces are these. So that's for one of my boundary conditions. Okay, so what I'll do is I'm gonna copy, paste it, and run. Okay, you can see I've created an automatic method and I've created body sizing, right? Both the selections are the same thing. It's just two different ways of doing it. So one is the non-efficient method and one is the efficient method with the name selection. Okay, so I'm going to clear this, and what I'll do is I'm going to have all my other meshes that I've created as well. I'm going to paste it there and paste it here and run it, so you can see all my other sizing. So that's my body sizing and so on. Okay, so once that's done, you can see how your script is slowly coming along. So you build it in your in your shell, and then you just copy paste it, which I'll not be doing it, but you can see how it's slowly coming along. Okay, and once that's done, I want to generate mesh. So I'm just going to mesh.generate mesh, and it's a function. You can see it has parentheses at the end. It doesn't return anything because it says void. So I'm going to call it, and the mesh should be done within 5 seconds because I've kept it relatively coarse. Okay, there you go. All right. For a first pass, it's a decent mesh. Cool. All right. Now, all I need to do is I need to add an acceleration and a fixed support. Okay. So I can, you know what? Let's go through this because I've been copy pasting too much. So acceleration equals. So I know acceleration is under analysis. So analysis dot add acceleration. There you go. It's a function. There you go. Creates a new acceleration, returns a new acceleration. Done. And I want to define it by components. I don't want it to be vectors. So I'll go acceleration ACC dot define by. Is it defined by? Yeah, it's defined by get or set. So I can go here. Equal load defined by, again, if it's autofill, you can just hit the autofill. You don't need to type it. I'm just going to hit enter. And once you hit dot, you can see all the properties or all the options, quote unquote, right? In this case, I want to change it to, I want to change it by components, right? From vector. So I'm going to hit that and hit enter. So change it to components. And now what I want to do is I want to change the Y component to, 2 millimeters per second. Right, so this is going to be a little different. Why? Because so what people would normally think would be, I'm just going to do this, right? Component equals quantity bracket open. Say I want 2. I said 2 comma it's acceleration, so it's millimeter per second squared. So second to the -2. Right. So people would think that'll work. Unfortunately, I think second is sec. Sorry. Actually, it wouldn't work. I can try it. There you go. Can't assign read-only properties. Okay, so if I go y component, it clearly says it's a get. It's not a set, right? So when I was doing this as well, I was like, yeah, what's happening? I couldn't get it to work. So what I did was I recorded it. So let's just record everything now. So record, right click, add, where's acceleration? Add acceleration. Because I think I can only have one acceleration, so I need that. And add acceleration, change that to components and have this as 10. Stop recording. So you can see we did the same thing as before, add acceleration, we defined it, but you can see how they've done it now. Y component.output, right? Again, not intuitive. I'll explain why. Set discrete value, 0, quantity, and this. Okay. Point being is, so time is in APDL. This is again going back to APDL. I don't have much experience with APDL, but this is the context. So time is an input in APDL. So if you want to set the time, you can write, instead of output in this particular code, you can set input, right? And then you're setting discrete value. In this case, I've only got one load step, right? Because if you go back to analysis setting, I've just got one here, right? So this 0 is because Python again starts with 0 indexing, so it's just 0. That's the 0. So, and output is all these values here, right? It's the old APDL way. Didn't make sense to me, but once you start getting used to it, then you'll be like, okay, I get it. So times the input was XYZ is the output. So output set variable 0 is the first load step, and we're giving it a quantity. In this case, I think I gave it 10. So that's 10 meters per meter second squared. Okay. So again, I've got this. That's the recorded version. I've got this in a coded version. I'm going to copy and paste it, and I'll delete this because I want to run my recording script. So again, you can see how it's a lot cleaner. Acceleration, components, quantity, you're done. All right. Next up, I want to add fixed supports. Fixed supports is relatively easy, so I'm not going to explain it. I'm going to paste it and just go through it. So it's under analysis. And we are adding a fixed support, and the location of it is a name selection dot faces, which I have here, which I think I went through previously. Okay. So now we're good to go. Let me copy and paste this. Right. So my boundary conditions are set up. My mesh is done. What else do I need? I might need to, let's add some solution setup. So I've got the solution set up. I don't think I need to explain this. You can see it's under solution. I'm adding a total deformation and equivalent stress. Okay. I'll copy and paste it, run it. Okay. So you can see total deformation, equivalent stress there. If I want to solve it, again, you can solve it your normal typical, but since we're doing it Python, let's do all Python and let's do solve, which is right here. And that's a function, enter, and this, yeah, it should solve without a problem, hopefully. Okay, so this is the first example that I had for you guys. I think, yeah, we're 12:15. Don't have enough time, but do you guys have any questions quickly, which I can take? Yes, no? Okay, guys, I don't think if we take a break, I don't think we'll have enough time, so I think I'll keep going. Can you programmatically set the 0th time step? Yes, you can. And 1 second, I have got that. I'm pretty sure I've got that here somewhere. So this is for, let me copy and paste it here so you guys can see it as well. So this is when I was just testing a few things out. So you can see, so that I had 2 time step in this case, so I'm giving it 2 time step. If you want to set the time step, you can go change that to input, and change this to, I don't know, time is sec, right? Yeah, sec, and that's sec as well. And that's pretty much it. So it'll be, say, 0.1, 0.1. How am I writing 0.1 and 0.2? Okay, so that's how you programmatically change your time step as well. Okay. Cool. Can you record object generator? That's from Dick. I don't know, Nick. I've actually never tried it because object generator is it's already an automation tool. So I've never tried recording it. If you want, give it a try. Let me know how it goes. But I think I might keep following up, going on with this one. Okay. So let's open up. I'm gonna minimize this. Let's open up what we've got. So what did we finish? We just finished trailer model example. All right. So now this is going to make a lot more sense key concepts wise. Because we've just gone through an example. Shortcuts, there's only two that I use a lot. Control up, up arrow, which I use quite a bit, I don't think. So, my shell is cleared now. Say if I want to go back to my last command, I hold control, hit up arrow, there you go, solution solved. If I want to go another one, there, I can keep going. Right. So everything on my Superman, NX, NS, everything is here. Okay, I can keep going. So that's one. Another one is a controlled space, which I use to force auto completion to reopen, which is super annoying because sometimes you always need to go back and hit period for it to reopen. Okay, so those are the most used shortcuts for me. But if you guys want, feel free to read up. I'll put it here regardless. All right. Again, autocomplete, I think we've gone through this before. We jumped a few steps, but it does give you good documentation on what are the inputs and what are the outputs. Okay, so enumerable, you can see enumerable is a list because you can enumerate over it or list over it. So you can read a few things. Again, some things are very Python heavy, which I did not understand at first. I was confused. Hey, why is it? How do I know this is a function? How do I know this is a property? A function would have parentheses. That's an easy way to put it. If you want to be real strict about it, you can go check it up in the documentation if it's a function or property. Okay. It'll tell you what what the output is. In this case, it says bool, which means it's going to be either a true or false output, right? So it'll tell you the input, what is the input, what the input should be, the syntax, the data type of the input, and the output data type. Okay. So another way, I think I should have covered this before. Another way, if I want to know whatever options are under connections. Okay, so if I go dir of connections and hit enter, it's going to be a massive list, but you can get, I'll make this bigger so everyone can see. You can get whatever is under connection, solution, contact tool, end release, figures, image, blah, blah, blah. You can do the same thing for analysis, and you'll get an even bigger list. What did I do? Analysis, there you go. There you go, which will have everything, whatever you need. So there's another way of doing it. Again, it's very daunting for someone to go through the search one by one. For the advanced users, you can use I forgot the terminology for this. I think it's list comprehension. Yeah, list comprehension for X in analysis. If start, I don't know, add or something, right? So this will give you. I'm not going to run it because I don't think this is going to work. But this will give you whatever methods or properties which starts from add in analysis. Okay, so there's ways to check check a few things. For advanced users, you can use all these, but if you're like me or if you're just starting off, you can go to the documentation like I did before and just search for whatever you need. If you need a remote, I don't know, point mass, just write point mass, and 90% of the time it'll come up here. So there you go, add point mass, and just go through what properties and classes it has here, what can be changed. You can see get set goes through here. Okay, cool. Let's go back to the presentation. General setup, I've given it here again. I'll paste it in the chat as well. I've had this as a proper code so everyone can copy paste it. So it'll be helpful for every single person. Geometry node element, just want to reiterate. I haven't touched on node IDs, element IDs, and so on. It's a bit hardcore. It's going to take some time. If you guys need any help, just shoot me an email. We'll have a separate session. Or if you guys are even interested, we can even have a session 3 later down the line with covering a little bit more advanced topics. We've gone through this recorded as coded. Why use recorded to find the syntax? Why not to use recorded? Because that 467501 or 540 IDs makes no sense. So find the syntax using recorded and then code it out by yourself using name selections. Okay, that's the general gist. Zip will come back to these three kind of Python things again, but to just simply put it, if you have two lists, in this case, think about a node number list and a node ID list. Okay, a node number, would have a node ID as well. So it's going to be two separate lists, right? In this case, list 1 and 2. And if you want to concurrently traverse in both the lists, equating, A to 1 or B to 2 or C to 3, you can use something called zip, right? Which I've gone through a little example here, which I'll be using as well. If time allows, we can do some quick examples as well, but you can use this as well. There's another way of doing it, a proper method for programmers out there, dictionary, called a dictionary, where you can have a key value pair. I don't have a slide for that, but I thought it's a bit, a lot of people wouldn't use it. But essentially what a key value pair is, in this case, key would be A and the value would be 1, right? You can find, you can go back and forth. If I give this value, what's the key for it? If I give this key, what's the value for it? It'll be useful when you're dealing with, say, in a programming sense, I'm programming, a timesheet for all the people in my office or something, and each person's bio, everyone has a name. So, and everyone's obviously they've got an age as well. So, say Tom is 24, Nick is 25, Nish is 21. So the names would be my keys, and my age would be my values. So that's kind of a generic use of a dictionary. Okay. Next one, Tiffany did mention this, but I just want to touch on this. So why is with used? So a with handle is used to to work with unmanaged resources. This is very important, and I can't stress enough why, because we would be opening the RC file, which is the result file which mechanical produces, right, as an output when it's finished solving. You can find it in the solver directory. When you are dealing with RC file, you're reading results, and so on. If you don't handle it properly, if you don't close it, you can potentially corrupt your file. Okay. So when using with, it'll close it automatically. So in here, you need to explicitly open the file and close it. If you use with, you just make an indentation, do all your thing, whatever you want to do within the file, and just forget about it. Right? It's just a safer method, and it also takes care of exceptions if there are any errors thrown at it. Okay. Next one I want to cover quickly is transaction. Again, it's I've got a little example at the bottom. So what a transaction does is, when if I go back to this particular example, when we did, I'm just going to clear this because it's too much. Let me bring that down. When we did all this, the GUI kept updating, right? If I want to quote unquote freeze the GUI, right, it'll take a lot less demand on the computer, and be efficient with it. You can use something called, where's my presentation, transaction, right? So how you'd use it is similar to zips and everything. You go with the transaction and you write your code in a block, in an indentation block, and keep going. So essentially your GUI would be frozen. In official terms, it does not require state updates, right? So if there's anything which requires a GUI update, this wouldn't work, or it'll throw out errors. So just be aware, okay, when writing large amount of codes and going through GUI at a rapid pace. Okay, so we covered that. Now let's go to the beam connection example. So as I said before, this was one of the most requested scripts of any of any customers in the last 1 year, easily. What they want to do is think about a model. In this case, I've got a simple model. But most of the customers got a model with about 600-700 bolts, right? You'd model a bolt as a beam in mechanical. One of the ways to model it, you can model it as a 3D bolt as well. But a lot of the people do model it as a beam connection. You want to automate this process. You can automate it using what I've gone through in the previous example, and also you want to get the axial forces, torques, and shear blob, whatever you need from mechanical to write it out to a CSV file. So, Ansys mechanical, we don't do any code checking. A lot of people require code checking as per the Australian standards, whatever it may be. So you would ideally like to have these in a neat, formatted Excel file or a CSV file in this case, so that you can take that into, you can just manipulate your CSV file and find what's happening. Okay, so I've got the example already here. I'm gonna get rid of this. So everything is solved here. So there's nothing fancy. I've just got an I-beam which is connected to a flat plate. Let me go display. I'll just blow it up a little bit. You can see the two I-beams. There's one flat plate there which is connected to the other flat plate. Let me just look it up in the settings. Yeah, you can see how it's connected. Okay, so reset that. Cool. Um, okay, now what I'll do is I'm going to copy paste because we are at the 12:30 mark and I want to have time for questions and so on and go through other things as well. I'm just going to copy paste the script that I have prepared already and just go through it one by one. And if you guys have questions, we can answer it. Right. So let me one sec. Let me just make this bigger. So we'll go through this. Okay, let's go through it from the start. So I always have this kind of tab up top called user inputs and remarks because it forces the users to input particular, all your variables, all your, uh, yeah, dependent variables, so to speak, independent variables, sorry, can be here, right? As per, I think one of the questions was, hey, can I have my Y coordinate up here? Yes, have it here, and I'll find a way to input that into my, beams or joints or so on. So in this case, I have analysis assist index as 0, right? As I said before, you might have multiple analysis system, modal, transient, etc., etc. In this case, I'm going to have 0, but again, that has to be user input. Say if the user wants to run it in a modal analysis, he's going to go there and count it and change to 1 or 2 or 3, whatever it might be. Okay. A CSV file. Tiffany's covered this, but I'll just quickly go through it. So this is the file path and the file name. So you can, again, be elaborate or fancy and import OS as a hardcore Python user and, a string join or path join these two. You can path join that and the name, but I've just kept it simple. I've called it test case and I've just put the path here, right? You have R here to make this a literal string. What that means is Python, if you go /n, it's considered a new line. So to consider this as a literal, quote unquote, literal string, you have the R at the front. Okay. Or I think another alternative is have triple forward slashes, right? But I just like this is just a cleaner way of doing it. Okay. We can get into units, but I don't recommend. I don't write in my CSV file. I don't write units at all. The reason being is the solver is in a consistent unit with whatever you're solving, so which can be which is here, right? But I want the users to check the units because if I write a unit, force time or acceleration, for instance, it's going to give me the pure unit, which is F is equal to MA. So it's going to give me kilogram and the acceleration is meter, millimeters or meters per second, right? Sec -2. So this is what's going to give me, and that would make no sense to me, right? As a force unit, sorry, not an acceleration, as a force, right? So force for me, and I'm sure this is other people as well. I'll just call it newtons, but that's how mechanical does it as well. So that's one reason I don't work with units. I just say please double check your units and make sure it's consistent with your solver units. All right. So John setup. This doesn't require much because it's a pretty simple problem. So I've just set up model analysis solution. I'm importing the CSV module here. And an index is coming from 0, which I've already explained. So I'll go through what I'm doing here. So I've got 6 beams. Okay. But I want to put them in a list. Right now, they're not in a list. So what I do is I create an empty list called probes, right? So empty list is this literally just square brackets to empty list, right? I'm using with transaction, by the way, which means the GUI is quote unquote frozen. Okay. You don't need to. I'm just doing it just because it's cleaner, right? You can easily just take that out and go back. All right. So I think someone's sorry. I'm just gonna mute. That's fine. Yeah. So let me, so for beam, again, a for loop, I'll explain what that is. Let me type that. So for beam, again, this can be anything. For me, it's just logical to have it as a beam because it is a beam at the end of the day. You can have, again, Superman, whatever name it might, you might want. For beam in model, I think I need to run my general entry points before I get that and enter. So my general entry points are there. Now let's do it for beam in model dot connections. So mechanical works. I mean, scripting in mechanical at least works in a way of you can access children, right? What I mean by that is beams right now is a child of connections, right? And this particular object, cylindrical, circular, sys2, blah blah blah, is a grandchild of connections. Okay, so in the programming sense, it made sense when I started. I mean, it's an easy concept to grasp, I feel like. So if I go get children, so what I'm doing is I'm getting the children underneath connections. So get children, hit that, open bracket, and it gives me a bunch of things here. So I'm just going to read it. So it's a list. That's my output right away. It's a data model object list. One is data model object category. That's just a syntax. They've given a little example here, so you can just copy that. And next one is a Boolean recursor. So whether to retrieve grandchildren recursively. In this case, I want the grandchildren. So it's a Boolean recursor. So I set that to true. So that's why I set it to true somewhere there, right? And what type do I want? I want beam, right? Again, this was not intuitive for me. So what I normally do before I even go this, before I come here, is I click there, click here, and go tree.active objects. And it says it's a beam. That's the type, right? So that's why and then I'll copy that here. So if you want to look at something else, I'm not sure, fix support or something, let's do that. So active items will get the active item that I've clicked, literally. So it's a quick way to debug and do things, right? See, hey, it's a boundary condition, it's a fixed support. Okay, so the type of that is beams. So what I do is I loop through all the beams under connections, right? Whether it be child or grandchild. And then what I do is I add a beam probe solution. So what I do is, you know how you drag and drop it to make it a beam probe? That's what I'm doing. So I've got 6 beams here. So I'd add 6 beam probes. And then what I do is, because if you drag and drop it, the location is already fixed because that's the, but in this case, because I'm adding a beam probe, where is my beam probe? Probe beam, there you go. The boundary condition is still blank. Yeah, so I need to give it a boundary condition. So there you go. So what I just did GUI wise, I'm just doing it programmatically. So I just go probe.boundary condition equals beam, right? Because when it loops through, this is all the first one. So it's going to give the first one. And then what I do is I append the probe, which is all my probes that I'm creating to this list called probes. Okay, you can append the beams as well, but I'm not doing it, but we can easily do that. That's not a problem as well. So what I mean by append is, so I'm going to call it apple equals, no, let's just keep it simple. List1 equals empty list, right? If I want to append to this, I'm going list1 append 1, done. And if I go list1, you can see once there. If I want to append, I don't know, 2 or 10, it's 10 again. I'm going to, then again, it's 1 and 10. So it'll keep adding to the empty list. All right, that's what append means. So what I do is, how many ever beam probes that I'm creating, it is going to keep adding these beam probe objects to a list called probes. Okay, and then what I do is I just evaluate the result, because this is already a solved result, right? I've got forces, I've got things here. Okay. So that's that. If there are any questions regarding this, just put it in chat. I'll get to it, but if not, I'll keep going for now. I'll make this bigger. So next up, what we do is I open a CSV file using the with handle. Open it and CSV out. That's my path, right? And my name test case is already there. And so this WB can be read, write, or write only. There's a bunch, there's a lot of quote unquote properties for CSV. You can find that in the CSV module as well. So in this case, I'm using WB as R file. So I'm just going to call that as R file. So whatever I just opened this, I'm going to refer to that as R file. And then what I do is I want to write. So csv.writer R file. And then so the first row, I'm going to just create a list and write this in my first cell. So maximum value over time. In my second row, what I'm going to write is I'm writing the beam name. I'm writing axial force, I'm writing torque, blah, blah, blah. Okay. All the variables. And then, so what I can do then, I'm just going to delete this. And then what I do is I created a list already called probes. I go through for probe in probes, right? It only makes sense because you have a bunch of probes and each item would be a single probe. So for a for loop, if you have multiples of something, if you have balls, right, you say for ball in balls, so whether it be basketball or football or whatever. So that's just a general just to make it easier for understanding, right? So for probe and probes, what we do is we write probe.boundaryCondition.name. So so the first row is pretty much this. Okay, the first row and the first column. And the second column would be the maximum, axial force value, which can be found by evaluating that, and maximum axial force would be 256.77. Okay, and I go through that. I go through that one by one to to loop through everything and get all my values set up there properly. Okay, so if there are any questions, just shout for this. So I'm just going to run this as well because we've done this. So what I'm going to do is run the script, which is run right here. So it says script executed. I've got all my beams created here. We know it's evaluated as well. So let's minimize everything. And I've got this here, test case. Double click. And you've got your, okay. Right. So one of the questions yesterday, which I could address as well, I think in this point, is the client wanted the beam name or the beam radius, I think, if I'm not wrong. So this is where I thought, zip would come into play, because now we want to loop for each, we want to loop through this list and this list at the same time, because that's what we're writing. So how I'd go about doing it, I'll do it interactively because I don't have this up. Hopefully it works. So beams equals empty list. I've got an empty list of beams. What do I need to do? So let's go through a for loop. So for beam in, because it's under connections, again, we'll do the same thing model. To be honest, I don't even need to do it. I can just copy and paste this. Copy, paste, and then shift enter because you're in a loop. So that you need to maintain the indentation. What I'm going to do is I'm just going to append the beams to beams.append. I'm just going to append the beam, every beam, to a list called beams. Okay, hit enter. Right now, if I go beams, technically there should be 6. Right? I can easily count that. I think there's a length 6. There you go. Okay, so now we've got all the beams under a list called beams. We've got all the probes in a list called probes. If I go write probes here, we should get a list of all the probes here. Okay, now we've got 2 lists and we are just looping through probes and writing all the values related with probes. But we want to write, I think it was the radius, if I'm not wrong. We want to write the radius as well. So what you would do is, I'm going to do it in one line, but if it's too confusing, let me know. I can try break it up. Okay, so it's going to be a for loop. So for probe, comma, beam in zip probes, comma, beams. Okay, I'll explain a little bit. So probe is referring to each object here. So this one particular object. Okay, beam is referring to one particular beam here, one item. in the list, right? A single element or a single item or whatever you call it, right? And then I'm zipping them together, right? So we can traverse through both the lists concurrently, right? Zip probes and beams. So probes is that list, beams is that list. Now, what do I want to do? I want to, in this case, I think it was that. Let me, sorry, print. I want to print it. Let's print the probe name. So probe dot name, and it was the radius, right? Yeah, it was beam dot radius. Okay, all right. There you go. So I've got beam, which is 10. Again, in this case, all the radiuses are the same, but you can see the use of zip, and you can see how, the logical method on how I go about doing it. So as I said before, a for loop is literally the most used loop in the last 2 years for me, at least. I think probably used once. I've used while loop once, and yes, if conditions and all the other things I use it on a regular basis. But for loop is the most important one. If you guys understand for loop and how to manipulate for loop and zips and enumerate and a few things with the for loop, it'll make your life easier, and you can get a lot done just with that one loop. Okay. So let's see what I've missed. So it's kind of what I went through here, and because it's a pretty famous example or most requested script, I've kind of pasted it here so that people can go through it as well. All right. So if it's 12:40, I can. There's only 3 slides. I can rush through it. So if you guys have any questions, just shout. I think there's a few questions. Is it possible to import the API library into regular IDE for code writing purposes before passing it into Mech? The mechanical API, you mean? Stephen, I don't think that it's possible to get the mechanical API. It's not publicly available because it's only Ansys related. So Ansys is it's a protected IP. Okay, so you can't take it into a regular IDE before coming here. And also, mechanical uses Python. So if you don't do it in the mechanical scripting, you wouldn't know the limitation of it. Okay. Next question. Can you do that but without the MM following the radius? So once you import into spreadsheet, you can use it for calculation. Yes, I can do that. Hopefully, let's go back to that thing. I'm just gonna go Control up arrow, right? This is my experience coming into play, but this should work. There you go. Right. Again, when you go hit dot, there's nothing here, but just because I've done this before, and I know it's just value, and you can see you've just got 10 there. Okay. Hope that answers your question, Michael. Stephen, no worries, thanks. No problem. Peter, does zip rely on the list being already aligned or the same? Yes, it does. Yeah, absolutely, it does. Right. So yeah, then it begs the question, hey, if you want it to be structured, then you'd probably use a dictionary, which is a curly bracket. I think the syntax would be, I don't know, Apple, comma, I don't know, 1 or something. So that'll be a key and that'll be a value. So if you want to be a little bit more rigid with your data type, but yes, zip does rely on you having your list in an orderly manner. Okay, cool. I think that's the question. Those are the only questions for now. So this is done. I'm just going to delete this script because I've got the graphics thing, which I'll just quickly skim through before the overview. Okay, let's go through this. So I've got the graphical kind of interface. I haven't touched a lot. There's quite a bit on this in the help file. So if you go, I think it was under, where is it? Scripting examples for interacting with results, or it has to be, yeah, there you go, graphics. There's quite a bit here. Probe animations. You can get the animation. Where is it? In an MP4 format, total definition, and so on. There's quite a lot here. I don't have the time to cover every single one, but I'll just touch on the most important one, I feel like. So let's go to it. So what I'm doing is I just want to import an image. A lot of people cannot control the resolution when they come in mechanical, but through the API you can. As you can see here, settings 2D point dot width equals that. Just go through from the start. I'm giving it a file name and file and the directory where I want to save it. In this case, I'm just going to call it image. Second line is me accessing the API. That's the syntax, answers.mechanical graphics, blah. And then what I do is I just go set each, functions in it. So system_studio.width and height, etc. So the black background I want it white because it's cleaner. Current graphic display, no. You can have that true as well. I don't have it. I don't know why I have it twice. That should be gone. I'll change that. And then I finally run the I run the function. Okay. You can turn on and off a few things by just using Boolean expression, graphic.show ruler. In this case, yeah, so this would be hidden, try would be hidden. You can turn on and off a few things. You can also manipulate the legend a lot. If I'm not wrong, manipulating graphics or where is it? Is I think it's one of the examples here. You can manipulate the legend quite a bit. I can't find it right now, but it's definitely here. And also the lighting as well, I think, which is here, model diffusivity and so on. Okay, so what I'll do is I'm just going to copy and paste this image just to show what can be done. So let me delete all of this. Delete, copy, paste. So I've gone through the code. I don't need this line of code because I forgot to delete that. And I'm just going to run it. So what do we expect? We expect a picture with a white background with that resolution with a name called image.png. That's the format in my desktop. All right. So I run it. It says script executed. I'm going to hide everything and you can clearly see the picture. Okay. Again, I didn't hide the triad or the ruler, but if you want, you can do it. All right. So going back, you have a lot of capabilities with the graphics. Didn't again, time did not allow. I did not cover in depth, but you can clearly see the depth it can go to in this sense. I just added an image, so that is from this image is from the help file. So I thought I'll go well together. Okay, so do we have any questions? We have 10 minutes. I can get into a lot more, but I think we'll give some time for questions. And general scripting in Workbench, I've got a few things here. If you guys are interested, we can go through the automation capability in Ansys. If you guys just want an overview so that, who'd be interested and so on. Can you specify the graphic output to select one of the items on the solution tree? Example, temperature, stress. I think you can. I'll just tell you the logic because I'm not done it. I'll just tell you the logic. So you can find the type of the solution, whether it be temperature, whether the temperature, displacement, or whatnot. And if the type is that, you can set the graphic type. So it's just an if statement. You should be able to do that. Benjamin Wang, is it possible to control the results to show deflection above a given number? Say deformations about 10 mm or 1 mm. Yes, you can do that using legend manipulation, which I did not cover, but it's readily available in the help file. Okay. Is it possible to save a camera position, get back to it using scripting? I believe in the beta, it is on the beta. Again, I said everything does not. You can see you can turn on the camera and graphics here. You can try it, but I'm not going to make any promises on that because I don't know. I haven't tried it. Okay. So with that said, let's wrap it up. I'm just going to go through quickly what is what is possible apart from mechanical scripting here. So we've got workbench scripting, right? So this is completely off. So mechanical scripting is done, by the way, just so that there's no confusion. So this is workbench scripting. You can work in workbench scripting. You can automate processes and workflows. So you connecting links together, geometries. You can change your geometry your what is it? Your material property here, I just made, this is the recorded version of me changing the density to 8,000 and I cleaned it up using a function here. Okay, that's just an example here. Again, not to mistake, this is not a replacement, or you can't manipulate the APDF file or the solver input file from here. This is again purely like mechanical scripting. You're just literally getting or setting values, which is already there. All right. So not all the GUI, not all the actions in GUI are recorded, right? You can use the record function as well. If I go back to Workbench, it's under View Scripting. You can start recording. So that's how you do, recording or run script. You can open the command window. This is the Workbench scripting, by the way. Okay. So that's Workbench scripting. DPF, it's called Data Processing Framework. So this is the go-to post-processing for Ansys throughout all the products. So even Fluent, from what I heard, and Mechanical, so pretty much all the products. So right now, this is already being used in the backend of Mechanical and also in the cloud. Okay, so it works in a pin to pin in, pin out, pin in, pin outlet basis. So in this case, I'm just getting the min and max of a displacement field. So I'm getting the time series, I'm getting the data source, which is the RST. I've got the code here if you guys are interested at all. And that gives, and then I'd retrieve the displacement, and then I normalize it, and then I'd write a function over it to find the min and max, and I get the output of the min and max of the displacement field. Okay, again, uses Python, but in the future, Ansys is trying to automate this so that people can just hook up tubes like this, so it's graphical and you don't need to know Python at all. Okay, that's DPF. We've done a project for one of the clients. It was a there's one of the first projects that we did with DPF, but I think it was a good one. We had to find any elastic strain above a particular limit, cap up the results, take it to convert it to STL, go to space claim. So this was all done using DPF and also ACT, which I'll touch on. So I opened space claim in the background. We've shrink wrapped it and then exported to a DSV file, which is what the client wanted, and then saved it in a location that he's needed. This was a whole project with the GUI and everything. So this was a full-on project. But again, just to showcase use of DPF in real life. Finally, coming to ACT, Ansys customization tools. What do we have? So ACT is for an advanced user who's got extensive background in coding, and also quote unquote a super user. So it's setting up, you can pretty much automate anything and everything. What I mean by that is you can manipulate the input file now. So you can write your own elements, you can write your own nodes and so on. So manipulate the solver. So you have to be really careful. Even if you're taking a stress result, you have to keep in mind, this is one of the mistakes I did. A stress is an elemental nodal result. It's not a nodal or elemental, it's an elemental nodal because it's an average from the Gaussian points where the integration is done. For the stiffness properties. So there's a lot of things to keep in mind when using ACT. To answer, I think it was one of the questions before, to develop an ACT, you need an enterprise license, but to use one, you can use it in any license. Okay, if you're interested, come give me a call or shoot me an email, come have a chat with me. But we've got some ACTs example that Leap's done. Before, which should be up in the Leap Learning Hub and the GitHub. So we've got something called last backup results. It'll make sense once you download the ACT and go through it, because I'm not going to go through it now. Finally, resources. Just to wrap things off, we've got Ansys Local Hub, which I've been using to show you guys quite a few things here. We've got the scripting documentation, which is the XML, which I told you guys how to get from here. We've got the ACT store. ACT store is where, hey, you can publish apps. So there's quite a bit here. A lot of them are free. A lot of them are paid as well. So you can I think Leap, you can add images and take images from Mechanical. There's already pre-built ACTs. I think we got some from Leap as well, if I'm not wrong, in the ACT store. Okay, so feel free to check that out. This one's from Leap. There you go, beam to link. And the way you do that is you go to Mechanical, and there's a little thing called App Store here. You can click on that and it'll open up. Okay, that's that. And to finish it off, finally, we've got the Leap Learning Hub. The tutorial, a lot of things here that I went through was not covered in the tutorial, because I thought if it's covered in the tutorial, what's the point of me going through it? So under the Leap Learning Hub, under structurals, Under structures, there's a little tab called mechanical scripting. Similar to all of the tabs, you've got one which you can download, right? And start downloading in a zip file. Okay. And finally, we've got the Leap Australia's GitHub. So me and Nish regularly contribute, and Tiffany as well, to be honest, nowadays, contribute to the GitHub. We've got most of the things should be up to date. We've got a few here. So check it out. Feel free to check it out. We've got all the ACT here. It's all free to download. Go for it. So ACT backup, Leap tools, and so on. So if you click on Leap tools, we can even look at our source code, how we've done things. So okay, there's a few things here. Okay. And finally, that is feel free to email support, as you guys know. And if it's relating, anything automation, mechanical related, or just scripting, ACTs, that's my email. What I'll do is I'll copy and paste my email again for anyone who wants it. Sorry, it's big. I'm not sure why it's that big, but yeah. Concluding, I think that should be it. If there are any questions, feel free to post it. We've still got 3 more minutes. We can extend it, 5 to 10 minutes. If not, that is all from my side and Tiffany. So thanks, guys. Thanks for showing up and asking a lot of questions. It was interactive. Feel free to reach out at any time.